All right. So hello and welcome to another lecture in on color reproduction in the ongoing series of lectures in pre-press repro technique. So till the last lecture, I believe that we had completed uh, almost the entire component of the corrections that basically are necessary for the correct tone for duplicating the correct tone reproduction or tone reproduction curve rather, and definitely the in order to achieve gray balance. So those discussions we have done. Today, from today onwards, we'll be studying our implementation, our part of implementation. So what is that? The question is, we know what are the components that are required and how to prepare those components. All right, in terms of what masks are required, why such masks are required, what precautions we need to take while preparation of those masks, what filters are required, why such filters are required, uh, what is the characteristics, I mean the tone characteristics of the negative that is required in the plate. So all these things we have already know, and previously only we have when discussing about the half tone reproduction process, we had also talked about the entire process of using the process camera and processes involved while preparation of half tone negatives and positives. So all these things we have already discussed. Now today, as you can see in front of you, we are mainly talking about a schematic, right? We are talking about a schematic of what processes are basically required and what processes are basically need to be followed in order for the preparation of film negatives and positives depending upon the requirement. Okay, so how to actually prepare such color separations, we will be talking mainly about three techniques. One is definitely that you can see in front of your screen is the direct screen color separation method. The second one will be indirect screen color separation method. Quite obvious that in direct screen, as you can see in front of you, we are preparing the plates directly from the negatives. But in that situation, the indirect one will be seeing that we'll be making some more intermediates like some positives from which ultimately the plate will be actually made. So there are advantages and disadvantages of both these techniques. So that is not really we'll not really discuss that at this particular stage. We'll be discussing at the end when we have completed our discussion on the individual color separation techniques, and of course in the end we'll also be talking briefly on the electronic method of color separation using of color scanners. So all these things we'll be discussing in maybe the next uh, three lectures or so, and the final lecture we'll be talking about the final physical correction of the films that have been reproduced through etching, flat etching, dot etching, and retouching, addition of details, and all that. So, with that, we will be coming to the end with this particular module. All right. So, as you can see in front of you, that what is the overall schematic of preparing direct screen color separation. As I already told, what is the significance of the term direct, that hopefully you all have understood by this time, that directly the plates are being prepared from the negative itself. So what is the first step? You take the original transparency with you. This is the original transparency that you have with us, and you have to prepare first of all the masks basically. All right, first step is preparation of masks. As we have already seen in the previous lectures also, that we will mostly use two masks for most of the purposes, but for if special masks are required, then we can use some other masks also. Here you can see that we are using basically two masks, right? One mask is prepared using the red filter. This will be used for correcting the green filter separation, and definitely the other mask is basically prepared using the green filter, which will be required for using for correcting the blue filter separation. Okay, so that is what you have seen over here from the different masks that we have prepared already. Using these masks, so two masks we have prepared. Using this mask, we will be using this mask in conjunction with the transparency, so that we can expose them with the corresponding principal density or complementary filters in order to prepare the cyan separation negative, green filter for magenta separation negative, the split filter for the black separation negative, and the blue filter for the yellow separation negative, right? And simply when we have prepared all these negatives along with the color with necessary color correcting masks in conjunction with color correcting masks, we will definitely, so remember we are using these negatives that we have prepared. These are basically screens, these are not continuous tone negatives. In the indirect process we'll be seeing we are using some continuous separation films also. So in this case a very straightforward method, no I mean lengthy process is required. Just first step is preparation of masks, uh, depending upon the color requirements, color correction requirements that is required for the transparency for the reproduction. Once the masks are produced, we will be using such masks using the to create the screen separation negatives, and finally from the screen separation negatives we will be printing, we will be creating the printing plates using the contact printer or the not the contact printer but the down frame basically, which you have already done in your first year classes, first year printing surface preparation classes. So this is basically the overview of the methodology or the schematic of how the direct screen color correction, color separation, I'm sorry, is basically done. Now let us see some of the other additional aspects that you have to keep in mind, or let us delve deeper into the various processes that are basically involved in the process of direct screen color separation. All right. So as I was saying, let us take a look at some of the important aspects that we need to take care of, or some of the important aspects that we need to discuss in regards to specifically direct screen color separation method. Okay. So first of all, one very important aspect that is for direct screen method for color separation is it is difficult to control accurately. Okay, a lithe type panchromatic film is used for separation negatives. The high contrast of lithe film causes them to have a high sensitivity to variations in both exposure and development. A slight change in exposure can cause a drastic change in the photographic result. A small change in development will also cause a very dramatic change in the negatives. That is why we need to understand this very critically, that accurate control of exposure and development is therefore most paramount and very much critical. Okay. Without accurate control, one must be willing to accept variations in the separations. It has to be repeatable, right? The past history of direct screen separation method indicates from a quality level that this is precisely what has happened. Too many bad separation negatives were used, giving the direct screen separation method, color separation method, not that good a name when it comes to methods for separating color screens. Okay. On the other hand, if these variations in the separation negatives are not accepted, remakes are required to produce an acceptable set of negatives. Then the economic advantage of direct screen method, which includes that limited number of separations are required for ultimately making the image carrier, that gets somehow affected adversely. Another factor in keeping the costs down in the direct screen method is the speed with which a set of separation is produced. Any means of speeding up the entire process will help cut the cost per separation, and that will definitely help in improving the cost effectiveness of the process. Uh, Here we would like to focus on methods to control exposure, development and contrast, and at the same time we'll also keep in mind how to reduce the number of remakes that might be required due to some errors in the entire process. And definitely one important aspect in any screen separation, conventional screen separation methods also talks about, also includes automation, because nowadays although we are not using that much of a what can I say, films, uh, and we are focused mainly on digital techniques for preparation of image carriers like CTP and all. Even if we had used CTCP in the earlier days, I'm sorry, CTF to in earlier days, where we have a CTF machine in our lab, so we can demonstrate how to prepare that, what are the internal mechanics of that, how it is exposed, how it is developed, and all that. These things will be actually done. Okay. Now, exposure techniques for making direct screen separation negatives are the same in principle as those techniques used for production of your grayscale halftone negatives using the contact screen method. Three exposures are employed. I hope that at this stage you already know what these three exposures are. So that is definitely the main exposure for improving the detail in the image, and the light illuminates the copy, then passes to the lit film through the contact screen. The image of the original transparency is transferred to the film with the main exposure. The location of the highlight is controlled by adjusting the length of the main exposure. Balance of three process color printers highlights is maintained with precise adjustment of the main exposure. The main exposure has little effect on the shadow areas of the separation negatives. The shadow areas of the screen separation negatives are exposed through the flash exposure, which is also referred to as the secondary exposure. Now, a flash exposure, as you might know, is a non-image exposure made to the film through the contact screen. A separate flash lamp is used, having illumination or intensity of the illumination very low compared to the main exposure, and then it is exposed. Now only the contact screen over the film is used during the flash exposure. The purpose of the flash exposure is what? To increase dots in the shadow area. So naturally this is going to lower the shadow contrast and help maintain detail in those areas. Without the flash, shadow areas would not have received sufficient light from the copy to produce the dots, because amount of reflection from the shadow areas is already very less. The refraction would have looked kind of dull and dirty. The third type of exposure is definitely this also, that is the bump exposure. I think I have a picture of all these three types of exposures somewhere in this particular slide. Okay, yeah, this one, yes, right. This bump exposure, which we sometimes refer to as the no screen exposure, like in the flash exposure we do not use any image for exposure, but in the bump exposure we will not use any screen. This is made to the copy, as I told you, without the screen. Obviously it is an image exposure, but it is called a no screen exposure. Without the screen in place, the result of the bump exposure is to increase the density of the separation negative only in the highlight areas. This effect basically helps in increasing the highlight contrast, right? If the planning has been done properly, then we will be noticing that the bump exposure is required primarily in the cyan separation negatives. A set of direct screen separations made with nearly equal highlights and proper shadow dot sizes without a bump exposure would have nearly the same dot sizes throughout the grayscale. To increase the amount of cyan dot in the midtone and shadow areas of the grayscale, a bump exposure is used to make the cyan separation negative along with the main exposure and the flash exposure. The bump must be only a small portion of the main exposure, similar to the flash exposure but a little bit higher, as it is made without the screen in place. Now this is quite obviously understandable why this is done. The highlight contrast, the increase in the highlight contrast is caused by the bump exposure, will help to produce a scale of printing dots in the separations similar to as I will be showing to you in this particular slide. I think I have it somewhere over here. Yes, similar to this particular nature, and will produce a neutral grayscale. So essentially to the production that is very much important for good color reproduction, and as we have already seen, these values are for control purposes of the gray balance and contrast. As we had seen earlier, there still may be areas of the reproduction that will drop out and not print effectively at all, while some areas of saturated, the highlight colors basically and dark shadows may print 100% solid areas, right? There is, you can say, another more sophisticated equipment for preparation of direct screen method, which I had crossed over here. This one, this in this particular case, it consists of an enlarger with a pulsed xenon light necessary for the exposures required for direct screen separation negatives. Usually included with this type of enlarger is an accurate timer for exposure control. Some enlargers have built-in banks of timers, one for each exposure. These are programmed to your film and processing conditions. Once programmed, there is no need to reprogram for each transparency, and it will be automatically, kind of set, right? So, an accurate method to make allowances for differences in transparencies, for variations in the color correcting masks, and in the different size changes must be used. Uh, Here, kind of a photosensitive device, it has to be used for measuring how much amount of light is actually striking the surface. When the enlarger is set up to make separations and transparency is placed in the negative carrier of the enlarger with the mask on top of the transparency. With the enlarger lights on, the image is projected onto the easel and size of the image is focused onto the size of the finished reproduction onto the transparency that we are going to prepare. Uh, with the help of the photosensitive device, it is also, since we are measuring the amount of light that is on falling onto the easel in the highlight area of the transparency, since it is the aim of the operator to make that light the same each time, he can adjust the aperture size until a standard amount of light is measured, and he may note it down and fix it basically. Another technique with some enlargers is to use the optimum aperture size for image sharpness and to vary the light intensity until the exact same amount of light is again measured in the highlight area on the easel. By standardizing the projected highlight, the programmed main exposure can remain constant for each process separation negative, and the light sensitive device will automatically take into account all the difference encountered in the mask transparencies. Now, to make a set of direct screen separation negatives on an enlarger will require the manipulation of the contact screen, the mask, and the litho pan film that we are using to get the actual image in the darkness to accomplish the main and flash exposure on each separation negative. Usually, only the cyan will need a bump exposure to maintain gray balance. With care to make the right exposure sequence and to ensure the minimum amount of dust that may be falling on the film, the operator should be able to complete the exposures in a for the four separation negatives in very a limited amount of time basically. The exposure sequence for contact direct screen separation negatives is the same as that used in the enlarger. The calibration method will be similar for both. The chief difference from the enlarger method is that the contact method with the contact method actually the transparency and the masks are placed in the vacuum frame just above the contact screen during the image or the main exposure. That I think I had the picture is describing exactly that method itself. Basically, the contact film on top of the lith film, and that is being exposed using our mask, and finally the transparency is also there. So ultimately, that is how we are doing the exposure. The flash exposure is made to the film through the screen only with the mask and transparency removed. There are special techniques to flash using the mask, but these will be discussed later. I will be discussing them. The bump exposure is made without the contact screen but with the transparency and mask over the litho pan film. This is less costly when it comes to with contact direct screen, but definitely there is the handling part is higher. Now, another method or another advantage of the contact direct screen method is the simplicity of re-registration. If one separation, for example, of a set is judged inadequate, it can be reshot at some later time without any special setup. It will be exactly the same as the other separations, whereas with an enlarger there is always that risk that the image size will not be the same and the entire set will have to be reshot. Okay, now we come to another important point, that is how to set up and calibrate the direct screen separations equipment for the method. Uh, the characteristics of the masks and separations will also be similar even if different brands of films are chosen for making the masks and separations. The color filters will be nearly the same for different brands of film and light sources. Only very minor differences will be encountered. So, to simplify the procedure, consider the contact method of direct screen separation, and you only have to realize that if we are using an enlarger, the masks and transparencies would be in the negative carrier of the enlarger instead of in the vacuum frame. So what we have to do, first of all, we have to position a point light with an automatic filter changer over a vacuum frame that I have shown you, that is visible. Place then a flash lamp alongside the point light. At least two timers will be needed along with the equipment, a register punch, some diffusion sheeting, and a gray contact screen will also be needed. Then it has to be, the screen has to be punched and fit into the register pins and all, and then the screen has to be angled, right? The angle of the screen for cyan, as I already informed you earlier also, for cyan it is 105, magenta you can say it is 75, black is 45, yellow is 90 or 0 degree. These will actually produce less amount of moire pattern in the skin tones, that if there is any skin tone basically, then it will produce less moire in the skin tone. Now this setup will help us to make both the masks and separation negatives using the same equipment without any major changes. If faster setup is required, a faster processing time is required, then multiple timers has to be used so that we do not have to recalibrate the timer once it has gone off, and so quicker operation basically, nothing else. The calibration of the darkroom equipment to the film and development conditions will be easier if you acquire the specific what is it, that the information brochure from the film, for example the nature of the characteristic curve for the film, etc. Some of the available information has already been shown to you. Some examples I had shown to you. Two color correcting masks are usually sufficient for color correction and tone compression with direct screen separations, but we will see that these are not enough in the indirect separation. These two are exposed with the first two filters in the point light. Both masks may be developed in an automatic film processor that contains either continuous tone chemistry or lithe type high contrast chemistry, and then they have to be checked that there are no roller or belt marks on the masks after processing on these images may show up in the separation. So as we know that because we are preparing in an automatic processor, what might happen is it is need to pass through multiple rollers, which is washing off the unexposed areas and using the developer solution on, so that during that abrasion no marks, basically no visible lines are available, are formed onto the masks, which may be ultimately transferred onto the reproduction, that is unwanted. Now after evaluating all the masks and the separations are made by trial and error until the correct main flash and bump exposures are determined, the first set of direct screen separation negatives will be the most difficult to make. The correct exposure times needed for the film and developer combination that you will be using have to be determined experimentally, starting from the characteristic data, but this will not be exactly the uh, nature of the data that we, or nature of the experience that we find out in the dark room. They need to be tweaked and adjusted finally. Now, direct screen halftone negatives made to print with the offset lithographic method on good coated paper as I have shown already, should be containing this much amount of dot areas. The highlight is considered here to be the whitest area of the transparency that contains the detail. A specular highlight, as those found in silverware or glassware, should not print at all. It should appear completely white, and that means no dot at all. The highlight dot location is controlled with the main exposure. To move it up or down the scale, that means whether we are reproducing a higher percentage dot as a highlight dot or a lower percentage dot as a highlight dot, we have to make the necessary adjustment. Less main exposure will make the highlights print darker, obviously, while more exposure will make them print lighter. Dots will be smaller. The amount of dot printing in the shadow areas is controlled by the flash exposure. To print less dot in the shadows, we have to use a longer flash exposure or secondary exposure, as we have already established in the earlier little bit. To print more dot in the shadow and make it darker, causing more saturated colors, we have to use definitely the flash exposure. The flash exposure can be adjusted to be the same length of time for all the three process color separations. It must be reminded here that the cyan separation negative must print about 10% more dot in the shadow areas to produce a neutral grayscale that we had already seen earlier. Also, the mask contrast should be adjusted so that no bump exposure is needed in the magenta, yellow and black separation negatives. The cyan separation negatives will require a bump exposure. Gray balance is achieved by printing a heavier cyan than magenta and yellow. The bump exposure will be a percent of the main exposure and will remain a constant percentage once established. For the middle tones, the midtones printing values are controlled by the amount of bump. The bump used to make the cyan will help to print more cyan in the shadows, even though the same flash exposure was used for all three process color separations. Calibration of the darkroom conditions to your film and processing conditions can be rather lengthy, and it's a trial and error method. However, once calibrated, the procedure becomes much more scientific, and it becomes less of a trial and error method. But accurate control of all exposure is a must if good production quotas are expected. Variation in succeeding transparencies and masks will have to be compensated for elimination of expensive redoing or reshots. Exposure compensation for transparency differences and mask variations was accomplished on enlarger by either varying the aperture size, as we have already mentioned earlier, or by varying the light intensity to equalize the light projected in the highlight area of the film, because we have a light sensitive photometer to detect how much light is falling basically. Contact direct screen does not allow for a convenient method to measure projected light, but by careful measurement of the highlight area of the transparency and mask on the densitometer, the combined densities can be used to calculate the correct main exposures for other transparencies. This is another thing that you have to be very much aware while counting or calculating the exposure controls. Now, as I already told, the flash exposure will not vary as much as and is not critical as the main exposure, because it is only creating dots in the shadow areas, which limits its amount of what should I say, the ultimate effect that it has on the final output reproduction. The location of highlight dots and the balance between the entire set in the highlights is controlled with the main exposure. The flash for most set of direct screen separations probably will remain fairly constant for a given processing time. So for example, we prefer maybe a flash exposure for 5 or 10 seconds like that. That comes from experience, and it remains constant, fairly constant throughout the various types. The bump exposure is required for the cyan printer to ensure that the neutral gray balance of the set of separations is maintained. The highlights will have to be nearly equal in size. The midtones will contain more cyan than magenta and yellow, as you can see over here. The shadows will also print more cyan than magenta and yellow, and that is quite visible from whatever data we have provided here. To get heavier cyan printing in the midtones when the highlight is balanced to the other separations, what is required? What is required in order to increase the highlight contrast from the midtones? Really, what is required? We need to use a bump exposure, right? That actually affects the highlight midtone highlight areas more, along with the main exposure readjusted. Once the correct percentage of the bump exposure and the percent of the main exposure is determined to produce a 65% dot in the mid-tone patch, it should not be changed, otherwise the gray balance would somehow be affected. Now hopefully you understand why I went into the pain of explaining all the tone reproduction curve, gray balance, how to achieve it, then actually coming back to the point where we are actually implementing those ideas in real life, right? So an easy way to control the percent bump that we are using is using a neutral density filter over the red filter during the bump exposure that allows only the percent bump necessary, making the percent bump fairly constant. By using the main exposure time already set on the timer, you get the correct bump necessary, and the neutral density, in addition to any other filter already over the point source of light during the main exposure, ensures this. To print less cyan in the midtones, we have to definitely use a lower percent bump. Obviously, just the reverse of it. Now, with the equipment that was just described, it is quite easy to make the bump exposure with the main exposure timer and the filters in positions, and the flash exposure with the flash timer and the flash lamp, and then the main exposure with the main exposure timer, not changing the main exposure timer, right? Since the timers were set before darkening the room, nothing was changed except the filter position. Once an operator gets used to working in the dark with the proper timers, he can expose the whole set of direct screen separation negatives without turning on the lights. That I think some of you have also developed that experience from your first year lab. The exposure of the complete set of separation negatives should not take more than 20 to 30 minutes at max. Uh, so this is another important point that you need to maintain, is that controlling exposure is only half the battle. Development control is another very important control, and a change in litho film development has the same effect as the change in film speed. More development has to be compensated for by changing all exposures the same log exposure amount. Now, the aim with automatic film processors is to maintain exact control of the developer at all times, allowing for no variation, so that the development time and the development impact remains the same throughout for different types of films. However, anyone who has used an automatic film processor knows it will and it may definitely vary. Direct screen separations are affected even more than your other grayscale halftones because of processor variation, and this must be taken into account. Processor control strips can be used to determine the effect of change in development will have on exposure. After determining the log exposure shift of the developer activity, you can then adjust your exposures to accommodate that shift. If you don't have full control over these control strips and you do not know how to interpret the log exposure changes, make a test cyan separation before going actually for the production unit. And you can calculate the log exposure change by noting down the number of steps change in the location of the highlight dot. So for example, if you find the highlight down is down the scale by 2 steps, measure the density of the mask plus transparency step tablet in that step, measure the mask transparency step tablet where you want the highlight to be located, and the density difference is the log exposure change in the exposure computer that is needed to reposition the highlight for all printers. The flash exposure will also have to be moved slightly for the changed development. The flash times, as I have already told you, they are not as critical as the main exposures, and it remains fairly constant. It bears fairly constant relationships. Another important point that I would like to highlight is always process an entire set of separation negatives at the same time. That way you ensure that all four separations get the same development. Your development would vary should someone run a large batch of duplicating films through the processor in the meantime. And controlling contrast is another very much important consideration with color printing. Separations that print too much of all three printers in the midtones will look obviously very dark, dirty, and it will lose completely all the details. The bump exposure is to control the balance of the cyan midtones in relation to the magenta and yellow midtones for gray balance. Now, what do you do if the magenta and yellow midtones are not printing the correct amount? They do not have a bump and it is not convenient to give them a bump, right? Then what to do? Now here the contrast of the direct screen separations can be controlled by controlling the midtones. Definitely the amount of dot printing throughout the grayscale is controlled with the main, flash and bump exposures. However, here one important thing is that the mask plays an important role in controlling the overall contrast too. The middle tones of the color reproductions are influenced most by the curved shape of the mask. So that if you remember the nonlinear mask that we had used, one method to evaluate a mask is to calculate the mask number. So I think I have a picture of it somehow. Yeah, this is actually not the picture for the mask, but it's the effect that the exposure is having on the log exposures are having on the nature of the percentage dot in the negatives that we have reproduced, that I just talked about a little bit earlier basically. Okay, so coming back to the topic of how the shape of the mask is influencing the midtones, right? One method to evaluate a mask is to calculate the mask number, right, that we have established earlier also. Higher the mask number, greater will be the highlight density. This is an indication of the mask shape also, right? Because the method of calculation of the mask number can be related to the middle tones of the printed reproduction, it is more dependent on the midtone percentages. The higher the mask number, higher is the highlight contrast obviously. The effect of the mask number is to change the amount of dot printing in the midtone control step. A higher mask number will make more dot print in the middle tone step in all the printers. To print less dot in the middle tone, lower the mask number. That will automatically reduce the shadow contrast as well, but it will also allow the printers to print less heavy in the mid-tone areas, right? The direct screen separations made with automatic film processing need a mask number of 0 for the best reproduction. A higher mask number made the reproduction appear too dark, right, because of higher shadow contrast and all. And A minus B density range, what is A minus B density range of the mask, was not altered. That is the mask number, essentially that is what the mask number refers. The other, you can say that is not really the mask number, but the range of density that is reproduced by the mask. That is also another important factor that we have to consider, because we are actually compensating or reducing the entire density range of the original to match it with that of the reproduction. So without affecting that, if we can change the mask number, then that is fine. So that impact will ultimately have on the midtones. It will allow the midtones to print less heavy colors, less heavy dots. Total amount of color correction necessary for printing inks dictated a 45% mask was necessary. That means a range on the mask of 0.9 was necessary when starting from a range of density range of 2 on the original step tablet. To print on paper of lower quality that is more absorbent, it may be necessary to lower the mask number, causing the middle tones to print less on or for all three process colors. Otherwise, the reproduction again will appear very much dark and dirty, etc. Some adjustments might also be required in the main as well as in the flash exposures. Okay, so this part hopefully is clear to. Now, some pen films do not lend themselves to changing curve shapes. When using a masking film with a straight line characteristic, it may be necessary to control the middle tones with another technique. Some adjustments may be via careful selection of gray contact screen. A shorter screen range, that is the basic density range, will give higher contrast, and its effect is that the adding of bump exposure or raising the mask number, that is to make the middle tones print larger dots, we are increasing. A gray screen BDR that is longer will effectively lower the highlight contrast and definitely print less in the midtones. The effect would be the same as lowering the mask number on other films. Still, another technique using the straight line masking films might be to adjust the overall density range to help favor the midtones, even though the amount of color correction would be affected. In this case, the contrast is more important here than the color correction, right? A gray balance is achieved by color reproductions by printing larger cyan dots throughout the grayscale from the highlight to the shadows. The direct screen method utilizes a bump exposure with the cyan to get this higher highlight contrast. Another method is to produce the higher highlight contrast without using a bump. That will is actually produced using a pre-angle screen with a basic density range that is shorter than the screens used for magenta, yellow and black. Hence, the automatically what will happen, the density range of the cyan will actually expand. A basic density range that is about zero point 0.2 shorter than the other three contact screens to give about the right amount of imbalance in the grayscale to affect gray balance. Elimination of bump exposure, especially in contact direct screen, can save a lot of production time over the long run. Another technique that sometimes may be used to help the color saturation in the shadow areas of the direct screen separations is flashing with the mask in register over the contact screen. This has the effect of lowering the amount of that printed in all the other shadow areas except where that color is needed to be printed heavy. So that cyan may be increased, keeping the magenta yellow lower. It acts to allow more saturation of each process color where needed without making the entire production too much dirty or heavy. It behaves in a manner similar to an undercolor removal mask. I will come to undercolor removal. Although you have some idea about undercolor removal already. I have shown, but I have not named it as undercolor removal. But you know what undercolor removal is. So except that it can affect all areas of the reproduction and not just blacks. An example of this technique in the magenta printer would be to make a magenta print 100% in a fire engine red while reducing the magenta in the surrounding areas. A flash without the mask would also make the surrounding areas print the prescribed amounts of magenta, but upon close examination that red probably would not print 100% magenta. Okay, so getting maximum production with the minimum costs require that transparencies be ganged and separated together in large groups so that large batches volume may be increased. Because of differences in the transparency exposures and development, the highlights may be different. To make the highlights equal so that each transparency produces the correct size highlight dot, one can place a sheet of neutral density filter over each transparency that will add enough density to make it equal to each other transparency. Here, the density readings of the transparency highlight should be included in the mask density. The mask will tend to make the highlights more equal, so that balancing should be done after the masks are made. The neutral density sheeting should be added to the masked side of the transparency. And the most convenient way to mount the pieces of neutral density sheeting is on a clear piece of film, the same size as the transparency, and punched onto the register pins over the mask, so that will ensure that a uniform size sheet is used. To make the neutral density sheeting, a typical technique is to develop sheets of unexposed litho orthofilm in the developer diluted by 2 parts of water. By developing sheets of film to different times, one can prepare a supply of neutral density sheeting to many levels of density for balancing transparency highlights. Since this neutral density sheeting is made from film, do not use this on the camera lens. We have to use gelatin filters over the lens. The procedure for making direct skin separation negatives are much the same for either enlarger or contact separations. One problem that can show its effect while enlarger is that of the Q factor or light scattering characteristics of silver halide films. Enlargers with condensers tend to be specular in nature. Densities as measured on a mask will appear as though they were more dense than placed in this type of enlarger, because due to specular reflection, the light reflecting back will not be captured by the densities by the densitometer. Exposure computations will be considerably more difficult unless an accurate measurement can be made of the light projecting to the easel of the enlarger, and If this problem is experienced, there can be two alternatives. The first is to lower the contrast of the mask. Shortening up the mask A B density range about zero point 0.1 will accomplish the same thing and help lower the exposures. The use of dye-layered mask instead of silver halide mask will eliminate the problems associated with this scattering, specular scattering in the enlarger. Extreme enlargements made from the original transparency will tend to look less grainy when using a dye masking material rather than a silver halide mask. And also control patches stripped up with the transparency for use in an enlarger should also be of the dye type density for the same kind of reasons. And exposure calculations will be extremely inaccurate if silver control patches are used in an enlarger. In a contact vacuum frame, the silver patches and masks can be used with no unusual problems. Flash exposures of direct screen separations made on an enlarger can be simplified with the use of several techniques. First, an integrated flash is a flash exposure made for the total length of the main exposure. The light is usually projected through small openings surrounding the lens of the enlarger. Since the light originates from the main light source of the enlarger, any variation due to maybe the voltage changes will automatically be compensated for by the integrator of the enlarger. The intensity of the flash lamp can be standardized for different range transparencies and for different magnifications with the use of a very sensitive photometer. The photometer is used to measure the shadow areas of the transparency as projected on the easel. Now, this measurement is taking into account not only the combined density of the mask plus transparency, but is measuring the amount of light caused by flare. The flash lamp in this case is attenuated so that a known amount of light will strike the film each time, regardless of all the other light contributing to the flash exposure. This is now very much an important process. Another type of flash technique employs the use of a luminescent panel that is swung into place just over the film panel of the easel. Since it is attached to the easel, its distance from the film will not change, right? Once calibrated to your film and processing conditions, the flash exposure can be standardized. Differences due to magnification changes will not affect this flash. Direct screen separations from reflection copy can be made in a process camera. Camera back masking is necessary, and the same techniques for calibrations are used for camera back masking as those used as an enlarger also. The control patches have different densities from those used for transparency masking, but for the aim points for the percent printing dots of the separation, they are similar. Calibrating camera back masks for the different light sources can be more difficult than calibrating techniques for transparency masking. These techniques, as well as the physical setup, they need a lot of calculation and they can be discussed at some other point. The masking procedure will be very much similar whether direct screen separations or indirect screen separations are being used. So ultimately what is happening by paying attention to all these small details, there is the differences between originals, balancing for highlights or gangs or transparencies with your neutral density filters and adjusting the different processing conditions. Definitely the quality level can be increased and it can be maintained. That is our aim, and the amount of productivity and efficiency of the system can also be enhanced, so we will get the right output first time and every time. Okay, so this was all about the entire process of basically correction, I mean the process of direct screen color separation method. This is more of an implementation part, so I'm not going into further details of how every calculation and all is done. So in the next lecture we will be discussing about the indirect method of color separation. Okay, so thank you for listening, thank you for your attention.